Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 10 going to present regarding soil erosion risk assessment. So before that, we start the presentation. My name is FARAH and my role is basically the project manager of the group.
Hi, my name is FARAH binti Abu Bakar. My role is as a map designer.
Hi, my name is NADIA. I am a system developer.
Hi, my name is KLGIS2. I'm a geospatial database.
Hi, I'm ASHRAF as a GIS analyst.
Hi, my name is KANAGESWARI. So I'm going to present the objective of our project. Soil erosion risk assessment is to evaluate the soil erosion in SIREH by identifying the factors that contribute to erosion accessibility. This involves assessing soil properties, land cover, topography, and rainfall condition to determine the likelihood of erosion occurrence. So our study area is here, SIREH, and I'll focus on zone 2. Thank you.
Hello, my name is ASHRAF. Okay, here I'm gonna present about the Russell element. Okay, the first one we have a rain erosibility factor R. Okay, here data we got from the rainfall data. Okay, that one is there is a value is 68. Okay, the latest one show the 67. This is not too different because our zone is too small from zone 2. Okay, the second one is soil erodibility factor K. We got it from the soil data where is the only one type of soil where is the value is 0.15. Okay, the third one we have a slope length and steepness factor LS. Okay, we got this from the DEM data. Okay, the dark one show is 0 and the light one show the 66. For the fourth element we have here is a vegetation cover management factor C. Okay, what we can see here, the highest one that is 1 is a bare land as a 1. Okay, the second one is a vegetation as a 0.28 and the lowest one there is a 0 as a water bodies. The highest one show a possibility erosion is gonna be happen. Okay, the last one we have a supporting conversion practice. Okay, the latest one show a practice already happen where is the SIREH already do something for avoid rainfall to impact the land.
Hi, I am Nadia. I'm going to explain about methodology. This data set undergo detailed processing to create digital map and raster layer that employ with GIS software. Subsequently, the raster model is employed to identify and predict soil erosion potential, taking into account factors like rainfall, soil type, DEM, land use, and conservation practice. So, we got the model builder by using raster model that this element have. So we multiply the element to get the A. A is the estimate average annual soil loss.
So my name is FARAH. So I'm going to present about the result analysis, especially in terms of why we choose raster model instead of the other model. So raster model is basically more flexible than the other analysis model, plus its precision in estimating and identifying soil erosion loss and risk is more accurate, and it also aligns with the main purpose of this study. And also we're using our GIS software in order to build the revised universal soil loss equation raster model using the model builder. So the raster equation that we have found it based on several literature review is basically E equals to R times K times LS times C and P, where E stands for estimated average annual soil loss, R is the rainfall and runoff factor, K is the soil factor, and LS is the slope length and the steepness of the factor, C is the cover management factor, and P is the support practices factor. So as you can see from this final output map, soil loss estimation at zone 2 SIREH Park, we have gone to around 3 locations of the park. So basically we have location A, which consists of high level of soil loss, and also location B, moderate level of soil loss, and lastly as a location C, very high level of soil loss. Basically indicate by using the classification average soil loss risk, which is a numerical range like less than 10 is basically risk level is very low, 11 to 50 is very low also, 50 to 100 is basically considered as moderate, 101 to 150 considered as high, and more than 150 considered as very high. So as for these two maps, it considered as also we have the analysis in terms of overlay or overlapping the layer of the raster model here, together with a buffer width set with 10-meter diameter. And this is basically the 3D soil erosion in SIREH part, which actually have the same map of this one, just but being visualized as a 3D map model. I think that's all from me. Thank you.
Hi, my name is FARAH binti Abubakar. I'm gonna present conclusion. The conclusion is the end of the product is to visualize and map out the idea to benefit SIREH Park's future soil erosion studies, and maybe guide to solve the existing issue with the proposed suggestion. And add-on disclaimer regarding to the data acquired for the analysis, it may not be accurate because the data used is 2 or 3 past year data. And for that, the display map will not present current situation and period. So for the acknowledgement, special thanks to the stakeholder Encik Faizal as the head management of SIREH Park and Puan Syafinas as the park development and researcher for their contribution to time throughout the process.
Alright, that's all for us. I'm gonna say thank you for our supervisor, Dr. Nur Hakim Yusuf, and also for our coordinator for this program, especially Dr. Shahabuddin bin Amuddin. So I think that's all from me. Thank you. Bye-bye.